All right, on to rationals. The function f of x equals x minus 8 times the quantity x plus 3 all over x squared plus 5x minus 24 is given. Which of the following describes the function f of x? So we need to find the domain and we need to find a horizontal asymptote. So we're hitting two things here. So this is what I have to do. I'm going to change this problem in two ways first. The first way that I'm going to change it is going to help me find the domain. So I'm not going to change the top. I'm going to leave the top factored out like so. What is that, a 3? I almost made it an 8. Whew. I'm going to leave the top factored out like that. I'm going to factor out the bottom, and two numbers that add up to 5 and multiply out to negative 24 are going to be x minus 8, x plus 3. Nope, x plus 8, x minus 3. That was a close one. So if I'm only focusing on the domain, I don't care about the top. Who cares? I'm only focusing on the numbers that I'm not allowed to plug in. And I'm not allowed to plug in negative 8 because that would make this guy 0, which would make the entire denominator 0, which makes the whole thing undefined. And I'm not allowed to plug in 3 because that would make that factor 0, which makes the whole bottom 0, which makes the whole thing undefined. So I am not allowed to plug in negative 8 and 3, which means I am allowed to plug in everything from negative infinity all the way up to negative 8, not including negative 8. So from negative 8 parentheses to negative 8 parentheses, all the way up to 3, right? And then union again, let me get rid of that comma, union again from 3 to infinity. So that is the domain that I'm allowed to use. This is me saying I'm allowed to plug in whatever I want, except not including negative 8 and not including 3. So that's going to take me not to here and not to here, but these guys are promising. Okay. Now I have to find the horizontal asymptote. Now the horizontal asymptote is found by taking the leading coefficient divided by the leading coefficient. All right, so I'm going to do that by rewriting this guy and foiling out the top. So if I FOIL out the top, I get x squared plus 3x minus 8x is minus 5x minus 24. And that's all over x squared plus 5x minus 24. So we take the leading coefficient divided by the leading coefficient. Since the degrees are the same, it's literally just the leading coefficient, which is invisible 1, divided by the leading coefficient, which is invisible 1, and 1 divided by 1 is 1. And since this is a horizontal asymptote, it's going to be a horizontal line, which is y equals 1. So y equals 1 is going to be my leading coefficient, so not u and not u, which eliminates u, and it does have a horizontal asymptote. Now, if you're like, whoa, 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 when won't it have a horizontal asymptote? If the degree in the numerator is higher than the degree in the denominator, then it won't. But since they're the same, everything simplifies out nicely to just a regular 1, which means my domain is u, and my horizontal asymptote is u, and my answer is u. Or as Soldier Boy would say, u! Oh, thanks for watching. The function f of x equals negative x cubed plus 3x squared plus x minus 5 all over 5x squared plus 7x minus 4 is given. Which of the following describes the end behavior of f? All right, so whenever you're trying to find the end behavior of a rational function, you take the leading term in the numerator and the leading term in the denominator and analyze that. Nothing else matters. So I have f of x equals negative x cubed divided by 5x squared. What you do to find the end behavior is, first off, we notice that the numerator's degree is higher than the denominator's degree, which means this is going to have end behavior at the infinities. We need to figure out which infinity it is. So why don't we simplify what we have? Negative x cubed over 5x squared is going to have me canceling out 2 x's in the numerator and the denominator, leaving me with a negative x on top and a 5 on the bottom. So the way you figure out end behavior when you have a larger degree in the numerator is you take turns plugging in your infinities and negative infinities. So they want me to do infinity first. So if I were to plug in positive infinity, which I know doesn't sound right, but that's what you do. You do negative positive infinity over 5. Negative infinity divided by 5 is still negative infinity. So the limit as x approaches positive infinity, of f of x is going to be negative infinity. So positive infinity goes to negative infinity, check, nope, check, nope, nope. Now let's do it again with a negative infinity. If I were to take what I have up here in red and plug in negative infinity, it would look like negative infinity over 5. Negative is positive, so positive infinity divided by 5 is still positive infinity. So we can say that as x approaches negative infinity of f of x, we go towards positive infinity. So nope, yep, yep, nope, nope. Leaving us with C as our possible and only option that will work. The function f of x equals x squared plus 2x minus 24 over x minus 4 is given. Which of the following describes the function of x? So we're talking about x-intercepts here. We're talking about vertical asymptotes or holes here. So what we need to do is take this guy, factor out the numerator, and see what we get. So if I rewrite out f of x, and think of two numbers that add up to 2 and multiply out to negative 24. Those two numbers would be x plus 6, x minus 4. And that's going to be all over x minus 4. Now, whenever you have a rational function like this, you're looking for those three things. You're looking for first a 0, which, by the way, x-intercept and 0 are the same exact thing. A 0 exists when you have just a factor upstairs and nothing like it downstairs, and that happens here. My magic numbers are going to be negative 6 because that makes this factor 0, positive 4 because that makes this factor 0, and positive 4. So since this factor up here is all alone by itself, you are a 0. Now, if you are looking for a hole exists where you have a factor upstairs that's the same exact thing as a factor downstairs, which means a hole is going to exist at 4. Now, what we don't have is a vertical asymptote. Those exist when you have a factor on the bottom that's nothing like a factor on the top. That doesn't exist here. The only thing we have is a 0, or they want us to word it as an x-intercept, same exact thing, at x equals negative 6, and we have a hole at x equals regular 4. And that's going to be B. So there you go, easy problem. Let f of x equals x times the quantity 4x minus 4 times the quantity x squared minus x minus 6 all over x plus 9. Which of the following x values would result in f of x is less than 0? This problem is terrible. So this is what I want to do. I want to get a nice visual of what this picture is going to look like so I can figure out what this guy is going to look like. Let's keep you the way you are, and then also factor you out off to the side here. So what I could do is leave x like x. Let's whip a 4 out and put it in front of that x, leaving us with x minus 1. Let's factor u out to x minus 3, x plus 2, and you can't do much with the bottom. Okay, you can't do much with the bottom, x plus 9. Now I have 4 factors living up here. Yes, you are a factor, so invisible parentheses right there. The magic numbers are going to be the numbers that make each factor equal to 0. So your magic number is 0 because plugging in 0 would make u 0 and make the whole thing 0. Same thing with 1, make u 0, the whole thing 0. Same thing with 3, same thing with negative 2. Okay, the magic number down here is negative 9. None of these numbers repeat, which means you are all zeros and you are a vertical asymptote. Okay, so if I were to graph this information so far, and again, by graphing, I mean we're going to sketch just a regular old graph, nothing fancy, right? We have negative 9 way over here, you're a vertical asymptote. Okay, we have negative 2 over here, we have 0 over here, we have 1 right here, and we have 3 right here. Okay, that's the information that we have so far. That's the information that we have so far. I can get more information, though, as to what this graph is going to look like. So information number one that I can get is I notice that, all right, well, I can find out what my y-intercept is by taking all the constants up here. So my constants would be, let me see, well, hold on. There is no constant up here. This is going to go through 0. How do I know that this is going to go through 0, 0? Because if I were to multiply everything out, I wouldn't have a plus 0 at the end. See, the way you find out what the y-intercept is you take whatever constant number that's upstairs and divide it by whatever constant number that's downstairs. Well, up here, my constant number would be a plus 0 because if I were to factor 4 throughout everything, I'm not going to have some number lingering around. So my y-intercept is going to be 0. So this is going to go through the origin. So that's going to count for something. That's going to count for something. Another thing that I can notice is I notice that, all right, well, I want to find out what the end behavior is so I can kind of draw a rough sketch of what this is going to be. The end behavior is found by taking x times 4x times x squared, which is 4x to the fourth, and dividing it by x. When you are positive and you are positive, A, and when B, your degree is higher than U, this goes to positive infinity as x moves along to the right and negative infinity as x moves along to the left. So that's going to be my end behavior. So I have enough information to draw myself a decent looking picture. So what this picture is going to look like is you're going to start down here. Okay, now as this is moving up, it's not going to hit a 0 at any point before my vertical asymptote. So this is going to come back down and never cross the x-axis and explode down there. Now since there's no multiplicity, it's going to reappear up here. Okay, it's going to come down, go through -2, and then come back up and go through 0. Okay. It's going to, now no asymptotes again, so it's going to come back down through the 1 and then back up through the regular 3 and go that way. Now, is this going to be the exact picture? No, absolutely not. But this is what this is going to give us. Now I have areas where I can tell where these numbers live. So for example, my job is to find out where stuff is negative. If x is -1, that means x is going to live somewhere in between here. That is negative, so you are a true statement so far. If x is 2, that means you're going to live between 1 and 3. That's negative as well. So you are also a true statement, so A is my answer right away. Now, if I were to look at an option that doesn't work, like B, if I were to plug in 0, I get 0, which is not less than 0. If I were to plug in 3, that is 0, which is not less than 0. If I were to plug in 5, that's going to live above the x-axis. So none of these would work. It's not like some of them would work. None of them would work. If I would plug in -8, that's over here. That's above the x-axis, so you don't work. If I were to plug in -4, same thing. That's above the x-axis. You wouldn't work. If I plugged in 6, that's way over here. That's above the x-axis. You wouldn't work. If I were to plug in 1, that's on the x-axis. You don't count. So A is the only option that works because of this picture that we were able to poorly, but accurately, somewhat accurately draw out. Very challenging problem, but we did it. In the xy plane, the graph of a rational function g of x has a vertical asymptote at x equals 2. Which of the following expressions could define g of x? So this is what we're looking at. Vertical asymptotes means you have a factor downstairs with, if it's x equals 2, is going to be x minus 2 because the 2 would make the bottom equal to 0. Now what I also see here is you have the potential of multiplicity. So either you have one of two options. You're going to have x minus 2 alone on the bottom, so that's option number 1. Or another option that you can have is if there has to be a repeat, if there has to be an x minus 2 over x minus 2, right now as this is written out, this is a whole. However, if I have more x minus 2's in the denominator, right, that's going to be a vertical asymptote. Now here's possible option number 3. Okay, and I'm not sure if that's going to show up here, but I'm noticing that there's some backwardsy things like U happening here. I just need a 2 to be the case. So if any of these x minus 2's actually look like 2 minus x's, that would still follow the rules because a 2 would make the bottom explode. Okay, so that's what we're looking at. So either an x minus 2 alone on the bottom, or an x minus 2 with more on the bottom, or a 2 minus x following the same exact rules. You have an x minus 2 upstairs and an x minus 2 downstairs. That's a whole because they're the same exact thing. A is not going to be an option. Okay, now you have this guy is basically, so x minus 2 is the same as that. It's just written backwards, but there's 2 of you up here and 2 of you down here. That is also a whole because it's the same exact amount, so you're not going to work. Okay. Your 2 minus x on the bottom. Now, before you freak out and say, that's 2 plus x, which means negative 2 is my magic number here, not regular 2. So since I have 2 on the bottom, which is more than I have up top, C is going to be my answer. Now, to close this out, if you're wondering, well, why is D not going to work? Because the magic number down here is going to be negative 2, not positive 2. So I don't even have the option of a vertical asymptote at positive 2 for D. So D is not a possibility. So C is weird because, you're looking at things written kind of in reverse order. But C does work in this case because it makes the 2 my magic number. And if there's 2 of them, great. Let a of x over b of x be f of x, where a is a linear function that passes through the x-axis at 5, and b is a quadratic function that passes through the x-axis at -1 and 5. All right, so this is what this is saying. A of x has a 0 at 5, which means a of x is x minus 5. B of x is going to have zeros cross the x-axis at -1, which means a factor of +1, and +5, which means a factor of x minus 5. Since f of x is given to us as a of x over b of x, we can write this whole guy out as x minus 5 over x plus 1 x minus 5. They want the vertical asymptotes. So the magic numbers for these guys are the numbers that make every factor, and yes, that is a factor, 0. So 5 would make the top 0, -1 would make the bottom 0, and 5 would make the bottom 0. When we have the same amount of numbers on the top and the bottom, that is a whole. Okay, that is not what we want here, but bonus. What we want here is the fact that -1 is my magic number on the bottom. So I have a vertical asymptote living at x equals -1. And so therefore my answer is A, baby. Given the graph of f, which of the following describes the function of f? So we're looking at these options and they want left-handed and right-handed limits at 4. Now, when you see something like this, the limit as x approaches 4 with a little negative, that means from the left. You are approaching 4, which is right here. And by the way, 4 appears to be a vertical asymptote. You are approaching 4 from the left. So this guy, which I'll demonstrate in blue, has me coming from the left. Oh no, an explosion. Oh, but we're not at 4 yet. Oh, we care about what's going on right here at this very moment. So the limit as x approaches 4 from the left is going to be going downward, which is -infinity. So similarly, the limit as x approaches 4 with a little plus sign means from the right. So as I go to 4 from the right, here I am, I'm going to 4, it didn't take long, we're going up, which means you're approaching +infinity. So the limit as x approaches 4 from the left is -infinity. So as x approaches 4 from the left is -infinity, check. Backwards, 4 from the left, -infinity, check. -infinity, check. +infinity, no, no. Okay. Also, as it approaches it from the right, we are going to +infinity. So from the right is -infinity, no. +infinity, check. +infinity, check. No. So did I make a problem where I literally have the same exact answer twice? Yes, I did. Stupid me. So thank you, ChatGPT, for failing me. Both of these guys will actually work. So I'm not sure why that happened when I made my problem, but it's basically literally the same exact answer, just flip-flopped. So in this one rare case, let's just pretend that this is select all that apply, and the answers are B and C. See, no problem, no harm, no foul. So the answer is B and C. Before Christ. The function g of x is given by g of x equals x minus 50 times the quantity x squared plus 90x plus 100 all over x squared minus 250. Which statement is false about g of x? So you want the lie. So let's see what we can do. Let's factor all this out. You can't do much with x minus 50. It's already x minus 50. This is going to be fun. Think of two numbers that add up to 90 and multiply out 100. Go ahead, think of it. You can't. They don't exist. You can't factor this out. At least not without our good friend, the quadratic formula, which I don't know if I need to whip out, but we'll see. Now on the bottom, this does factor out. This is difference of squares to x minus 50, x plus 50. So what's important to know about this guy right here, right, is let me just write out one more set of factoring things, okay? This is going to be x minus 50, nothing changes there. This does factor out, but both of these numbers are going to be ugly, terrible numbers because you would only be able to do this using the quadratic formula. So whatever numbers they are, they're not going to be pretty. It's not like they're going to factor out and you're going to get like x equals 1 and x equals, no, they're going to be bad. Down here, you get x minus 50 and x plus 50. So the magic numbers here are going to be 50, some negative ugly number, another negative ugly number, 50, and negative 50. So at the very least, this is what I definitely know. Okay, what I definitely know. U and U are the same, which means 50 is a whole. Negative 50. And by the way, same thing with regular 50, since the only way that you're going to get answers for this, they're going to be ugly numbers, there's no way that any of them are going to be 50. So none of these are going to match up, none of them. So negative 50 is a vertical asymptote no matter what. And whatever these guys are, who cares, they're going to be zeros. Okay, so a whole exists at 50. Is that a true statement? Yes. I want the false statement, so A is not going to work for me. A vertical asymptote exists at negative 50. Is that a true statement? Yes, so you're not the one I want. This graph will appear linear. Now, a graph will appear linear if something like this happens. Now, this is what's going to happen. What the graph will look like is it will look like me crossing this out. So this graph is going to look like me getting rid of the x minus 50s and me being left with some ugly x, no comment, and another ugly x, no comment on my dating history, all over x plus 50. Now that's going to look like x squared blah 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 over x blah blah blah. That is not linear. That's not going to look linear. And before you get excited and say, but x squared over x, I know that, but nothing here is going to cross out. So this is going to maintain rational behavior. It's going to look like this, it's going to look like that, no matter what you do. Okay, so this will not appear linear, which means this is going to be my false statement. This is the one that I want. Okay, now if you're wondering g of 0 equals 2, what does that mean? Well, that means if I were to plug in 0, would I get 2? Well, let's find out if I were to plug in 0 by doing very quick math. If I plug in 0, you would go away, you would go away, you would go away, you would go away. So I would be left with negative 50 times 100, which is negative 5,000, over negative 2,500. Negative divided by a negative is a positive. 5,000 over 2,500 is 2. So you are a true statement. So C, this graph will appear linear, is the only one that won't work. It's the false one, which means it's the one that we want. We want the lie, and the devil is a liar. But in this case, we're going with it. So like and subscribe, please. Given a rational function with zeros at x equals 8 and x equals -5, a vertical asymptote at x equals -8, and a whole at 2, which of the following could represent the factored form of this function? All right, so let's build ourselves what we have. If it has a 0 at 8 and -5, that means you're going to have parentheses living in the numerator only. And the factors that you're going to build are going to be factors whose 8 and -5 make this whole thing equal to 0. So the only way that would work is if you have 8, you're going to make a factor of x minus 8, the opposite. If you have -5, you're going to have a factor of x plus 5, the opposite. Because plugging in 8 would make you 0, plugging in -5 would make you 0. That's the zeros part. If it has a vertical asymptote, that means there's going to be a factor living in the denominator all alone by itself. If -8 would make the factor equal to 0, then +8 is going to have to be my factor. If it has a whole at 2, that means you're going to have upstairs and downstairs being represented. Now, if it's at 2, a number that would make a factor turn into 0 would be its opposite, -2 and -2. So this is a possible factored form of the function. So x minus 8, x plus 5, x plus 2, nope. X minus 8, x plus 5, x minus 2, check. X plus 8, x minus 2, check. B is going to be my guy. Now let's just double check the others. X minus 8, nope. X minus 5, nope. And then x minus 8, x plus 5, good, but we're missing the x minus 2 up here. So you're a nope, you're a nope, and you're a nope, and you're the yes. So B is going to be my answer. Given the function f of x equals x squared minus x minus 6, which of the following describes the values of x for which f of x is greater than 0? Ugh. So this is what we have to do here. We have a lot going on. We have to find zeros, we have to find wholes, and we have to find vertical asymptotes. Not only should we do that, we need to find the end behavior of what's going on here, and we really should find out what the y-intercept is. So let's leave that looking like that because I'm going to come back and reference this in a minute. Okay. What I also want to do is I want to factor out the numerator and the denominator because that would give me wholes, vertical asymptotes, and zeros. So f of x is going to be factored out x minus 3, x plus 2. On the bottom in the denominator, we have x minus 3, x plus 3 because it's difference of squares. Now let's find the magic numbers, the numbers that would make each factor equal to 0. Your magic number is 3, your magic number is -2, your magic number is 3, your magic number is -3. So that would give you a, let me see, 3 and 3 repeat, so we would have a whole at x equals 3 because we have repetition there, top and bottom. -2 is a magic number living alone in the numerator, so that is a 0 at x equals -2. And -3 is a magic number living alone in the denominator, so I'm going to have a vertical asymptote at -3. So if I were to draw some important information on a coordinate plane, if I were to sketch this, what I have so far is I have a whole happening at 3, I have a 0 happening at -2, and I have a vertical asymptote happening at -3. So this happens so far. What I also need to find out is a y-intercept and a horizontal asymptote. Let's do the horizontal asymptote first. Now the horizontal asymptote is going to live whenever you have either the degrees are the same in the numerator and the denominator, or the degree in the denominator is higher. You're going to have a horizontal asymptote. These are the same. So my horizontal asymptote is going to be at x squared over x squared. You're looking for the leading coefficient divided by the leading coefficient. Each leading coefficient is 1 and 1. So I'm going to have a horizontal asymptote at y equals 1. So if I were to call U1, this happens, horizontal asymptote, at x equals 1, y equals 1, sorry. Now, the other thing that I didn't find out is where this is going to be my y-intercept. My y-intercept happens when you have the constant number in the numerator divided by the constant number in the denominator. That is going to be my y-intercept, and that's going to happen at -6 over -9, which is going to be 2/3. So this is going to happen. Okay? So let's, again, evaluate what we have. We have a whole at 3. Okay? This is going to go through -2. Okay? Now, it levels out at 1. So since starting from the left, I have a picture that levels out at 1, right, but doesn't go through any zeros at all, and then all of a sudden explodes here at -3. What this is going to look like is it's going to level out at -1 or +1 and then go like this. That's what I have so far. Then, since there's no multiplicity ruining things at -3, I'm going to reappear down there. And I'm going to come up and go through -2, through -2, because it's a 0, through that y-intercept of 2/3, and level out here while hitting a 0 or a hole at 3 right there. So that's going to be what my picture looks like. Now, what I'm supposed to do is I'm supposed to find out where this is greater than 0. Okay, so this is going to be greater than 0 here. All right, it's going to be greater than 0 all the way up till -3. It's going to be positive. So all the way up until -3, it's going to be positive. Then from -3 to -2, we're negative. Okay, but then from here on out, from -2 all the way until positive infinity, we're living in positive land again. So it's going to be positive from -infinity to -3. Okay, it's going to be negative from -3 to -2, and then from -2 all the way on to positive infinity, we're above the x-axis again. Okay, so that is going to be A. And that's how you do it. Simplify the expression x minus 2 to the 5th, which of the following is the correct expanded form. Oh yes, Pascal's triangle and the binomial theorem. So what we need to do is we need to build 5 degrees of Pascal's triangle, which means 6 levels of Pascal's triangle. So degree 0 is 1, degree 1 is 1 and 1, degree 2 is 1, 2, 1. Degree 3 is going to be 1, 3, 3, 1. And by the way that I'm doing this is add u up to get 3, add u up to get 3. So the next one is going to always be 1 on the outside. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then 1. This is 1, 2, 3, 4, 5. So the next one is the last one that we have to do. So degree 0, degree 1, degree 2, degree 3, degree 4, and degree 5 is going to be 1, 5, 10, 10, 5, 1. So building our binomial theorem has me start out with writing these numbers. So 1, 5, 10, 10, 5, 1. Then what I do is I label u A and I label u B. B is -2, by the way, not 2. A is x. So I will start out by writing out my A's and B's. All the ways start out with the left at the biggest A, so since I have to the 5th, it's going to be A to the 5th, A to the 4th, that's a B, A to the 4th, A to the 3rd, A squared, A, and never an A at the end. Watch what I do here. Actually, I don't need it, because I want different colors. I'm going to be creative here. Now do your B's all the way from the right, B to the 5th, B to the 4th, B to the 3rd, B squared, B, no B all the way to the left. So that's going to be plus sign, plus sign, plus sign, plus sign, plus sign. Now let's plug in what we have. 1 is 1, a is x, x to the fifth, plus 5 is 5, a is x, x to the fourth, b is negative 2, plus 10, a is x, x to the third, b is negative 2 squared, plus 10, a is x, x squared, b is negative 2 cubed, plus 5, a is x, b is negative 2 to the fourth, plus 1, no a, b is negative 2 to the fifth. Now it's just a terrible looking PEMDAS problem. 1 is 1, you don't need it anymore. X to the fifth is x to the fifth. Plus 5 times x to the fourth times negative 2, we'll clean that up. Plus 10 times x to the third, negative 2 squared is positive 4, we'll clean that up. Plus 10 x squared, negative 2 to the third is negative 8, we'll clean that up. Plus 5, x is x, negative 2 to the fourth is 16, we'll clean that up. Plus 1, negative 2 to the fifth is negative 32, we'll clean that up. X to the fifth is x to the fifth, 5 times negative 2 is negative 10, x to the fourth. 4 times 10 is 40, so plus 40, x cubed. Negative 8 times 10 is negative 80, negative 80x squared. 5 times 16 is also 80, but this is positive, positive 60x, 80x. And then 1 times negative 32 is minus 32. So x to the fifth minus 5x to the fourth, 10x to the fourth, plus 40x to the third, minus 80x squared, plus 80x minus 32 is going to be C. So, not pleasant, but we did it. What is the third term in the expanded form of 2x plus 3, that quantity to the fifth power? All right, well, what we need to do is we need to build ourselves Pascal's triangle. And we're going to build 6 levels because you start out with degree 0 at 1, and then 1 and 1 is degree 1, and then you just start building it. 1, 2, 1. You always add these two numbers to get the in-between number underneath. 1, 3, 3, 1. This is degree, so degree 0, 1, 2, 3. So I've got 2 more to go. 1, 4, 6, 4, 1. So degree 0, 1, 2, 3, 4. And finally, degree 5 is going to be 1, 5, 10, 10, 5, 1. So in order to build the binomial theorem, we have 1, 5, 10, 10, 5, 1. Okay, now I'll label u A, 2x is going to be my A, and I'll label u B. So you always start out with your a's at the left, start out with a to the fifth power, and then work your way down. A to the fifth, a to the fourth, a to the third, a squared, a. The last one will never have an a attached to it. Do the same thing with your b. Okay, b to the fifth, b to the fourth, b to the third, b squared, b, no b there, plus signs in between. Now the nice thing about this guy is we don't have to do the whole thing. We only have to find the third term. So the third term is going to be 10a cubed b squared. We called a 2x, so 10 times 2x cubed, and we called b 3, so 3 squared. 10 is 10. 2 times 2 times 2 is 8. X times x times x is x to the third. And 3 squared is 9. 10 times 8 is 80. 80 times 9 is 720. X to the third is x to the third. B is going to be my guy. Find the slant asymptote of the function g of x equals x cubed minus 2x squared plus x minus 6 all over x squared minus 1. A slant asymptote exists when the degree in the numerator is 1 degree higher than the degree in the denominator, and that's what we have here. So we use polynomial long division to do that. Okay, put that guy underneath the division symbol. Keep in mind if you have any terms missing in between, you have to fill it in with a 0. So I don't think that happens here. X cubed minus 2x squared plus x minus 6. But that does happen here. X squared minus 1 is missing a 0x in between. So x squared plus 0x minus 1. And then you just do polynomial long division. X squared times what is x cubed? X squared times x is x cubed. So you write the x up here. Multiply x to this factor right here. X times x is x, x times x squared is x cubed. X times 0x is 0x squared. X times negative 1 is negative x. Now we're going to subtract the entire red row here, which means flip the signs. You become a minus, you become a minus, you become a plus. The first guy will always disappear. Negative 2x squared minus 0x squared is negative 2x squared. Plus 2x minus 6. And then you repeat. X squared times what gives you negative 2x squared? Negative 2. Now at this stage, we can be done. And if you're like, why? Well, because the slant asymptote is found by polynomial long division, but you don't care about the remainder. So doing the rest of this problem would only serve one purpose, and that would be to find the remainder. And we don't have to do that here. So this guy is going to be the linear equation that represents our slant asymptote, and that linear equation is y equals x minus 2. So it's going to be B. All right, so polynomial long division, we don't care about the remainder. You just have to be careful of missing terms in between, and that's how you do it. Given the table of values for f, where we have a bunch of x's and we have an f, let g of x equals f times the quantity 3 times x minus 1, close it, plus 2. What is the value of g of 2? All right, okay. G of 2 is going to equal f of 3 times 2 minus 1, close it, plus 2. So let's do some PEMDAS. F of 3 times 1, close it, plus 2 is going to be f of 3 plus 2. Well, what's f of 3? Oh, let's go to our table over here where our f of x's live. When x is 3, we get 8. So f of 3 is 8, and 8 plus 2 is 10. So g of 2 is 10, and 10 is going to be my answer. The function f of x equals x squared minus 1 is transformed into the function g of x equals x squared divided by 5 minus 1. So the only difference between these guys is x squared is being divided by 5. I don't like the way that looks. I don't like dividing it by 5. I like throwing a 1/5 out in front instead. It's the same exact thing. Which of the following best describes the transformation of the graph of f of x, which look like this, right, to g of x, which now looks like that? Well, when we multiply the x squared by 1/5, what you're doing is a vertical dilation. And when you have a vertical dilation, you dilate it by the same scale factor that that number is. So a vertical dilation by a scale factor of 1/5 is going to be the only change, and it's going to be that guy. Okay? Which means you're squeezing it down. But that's how you do it. The function f of x has a domain of -1 to 3 and a range of 2 to 4. This problem is terrible. The function g of x is -2 times the quantity f of x minus 1 plus 3 is the transformation of f. What are the domain and range of g of x? So let's sketch out what f of x could potentially look like. Okay, what it could potentially look like, and I am awful at these. So let's go out to 1, 2, 3, 4, 5, 6, 7, 8. Let's go out to 8 because that's the largest number that we see in the multiple choice options here. So let's just stick with that. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. F of x lives in between -1 and 3, so here, and between 2 and 4. So it's going to live between this, so -1 and 3 starting at 2, up to -1 and 3 to 4. So my graph is going to live here. Now what we're going to do is we're going to transform each point that we have in the corner here and see where that lands us. Okay, now let's see what we're supposed to do. All right, -2 means the first thing that we're going to do is we're going to reflect over the x-axis. Okay, that's going to be the first thing that we do. Okay, Chekaruski. The second thing that we do is that 2 means that we're going to make it 2 times taller. X minus 1 is a horizontal translation. In other words, you move, in this case, to the right. And if you're like, whoa, 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 it's negative. I know, everything is opposite inside the parentheses. This is going to have us moving right 1. And then that plus 3 on the outside is going to have us moving up 3. So we're going to take each point, right? We're going to take each point here, 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 and here. We're going to reflect it over the x-axis because that's what that negative living outside the f of x means. We're going to make it 2 times taller. We're going to then move it right 1 and then move it up 3. All right, so let's take this point down here. Reflecting that point down there over the x-axis means we're 2 above now. Let's move it 2 below. Now we're going to make it 2 times taller. If it's -2 feet tall, and I know that doesn't make sense, but if it's -2 feet tall, making it 2 times taller makes it -4 feet tall. So now we're at -1, -4. Move it to the right 1, move it up 1, 2, 3, and that's where we live now. Okay? So let's do it again. Okay? Take that x, which is 4 above, reflect it over the x-axis, which moves it 1, 2, 3, 4 below. I've heard of 5 below, but 4 below, that's cheaper. All right. We are now 4 below, making it 2 times taller makes it 1, 2, 3, 4. So 8 below, move it right 1, move it up 1, 2, 3, and now we're living at the point 0, -5. Let's do it again for this point here. Reflect it over the x-axis, 1, 2, 1, 2. Okay, so now you live at 3, -2. Make it 2 times taller, making it live at 3, -4. Move it right 1, move it up 1, 2, 3, and now you live at 4, -1. Okay, one more time with this point right here. It's living 4 above, so reflecting it moves it 4 below. Make it 2 times taller, so 4 below moves it down to 8 below. So now we're at 3, -8. Move it right 1 to 4, -8, and move it up 1, 2, 3 to 4, -5. So my new picture lives here. My new domain is going to be from 0 to 4. So my new domain is going to be from 0 to 4. And my new range is going to be from -1, 2, 3, 4, 5 to -1. Terrible, terrible, awful, gross problem. But that's how you do it. An open top box is to be made from a 24-inch by 36-inch piece of cardboard by removing a square from each corner of the box and folding the flaps on each side. Let's get a visual. Okay, so we have a piece of cardboard, right? 36 by 24. We are cutting out little boxes, okay, little squares out of each corner, the same exact square, so that once we remove that, we should be able to fold these guys up and make ourselves a nice little box that looks something like this. Perfectly drawn. That's what we're looking at. Now, can you cut out 13 inches by 13 inches from each corner? Well, if I cut out 13 inches by 13 inches, that's a grand total. If I cut it out on this side, that's a grand total of me cutting out 26 inches. That's fine. Oh, but you know what? If I try to cut out 13 inches by 13 inches, that's not 16. I take it back. That's, well, if I cut out 13 by 13, that's me cutting out 26 inches from this whole thing. You can't do that. You can't cut out 26 inches from something that's 24. So the answer is no, no. So not yes, not yes. No, because the remaining length will be negative if you do that. So that's not possible. You can't do it. So B is going to be my option. So that's what's a domain restriction. That's called a domain restriction or a restricted domain, however you want to call it. But now you can't do it. Given the following data for x and f of x, so we have all this information right here, which of the following statements is true about the function based on the differences? Well, first things first, you each go up by 2, praise the Lord. So we have equal length input value intervals going on the left. So that means what I can do is if I wanted to find out if it was quadratic or cubic, I could do the same thing over here. So linear is not the option, but we'll test its linearity by finding out what we have to do to each number to get from one number to the next. Now, what you have to be very, very, very careful of is not making a dumb little math error, which I'm deathly afraid I'm going to do. So to get from 97 to 405, you are looking at a change of 308. 977 is going to be 275, so I can handle that. 1861 minus 977. I am not typing this into a calculator off to the side, so I don't appreciate your accusations. 3,105, 1861, the year I was born, is a difference between 1,244, and the difference between 4,757 and 3,105 is going to be 1652. So yeah, not linear. So let's see if it's quadratic. Please, Lord, let it be quadratic. To get from 308 to 572, you are looking at a difference of 264. To get from 572 to 884, you're looking at a difference of 312. So it's not going to be quadratic. To get from 884 to 1244, you're looking at a difference of 1020. 1244, I mean, I'm not typing this into a calculator off to the side. Minus 884 is 360. And then you have 1652. And 1244 is 408. All right, so it's definitely not quadratic. It's definitely not quadratic. So this better be cubic. So cubic is going to be 312 minus 264, which is 48. Looking at you, you're also 48. Looking at you, you're also 48. So this is cubic. And the reason why it's cubic is because the 1, 2, third differences are a non-zero constant. So the third differences are a non-zero constant. So I'm not going to lie. I would never lie to you guys. I used my calculator for this. Now, you could do this without a calculator, but that would make my video 2 times longer, which would make me 2 times more money, which is good for me, but you don't need to sit through that. But yeah, that's how you do it. The table below shows the amount of rainfall in inches over time in hours, and the pattern is linear. So we have time in hours, we have rainfall in inches. It's asking me to find out what R of 9 is and explain what it means in this context. Now, this is a calculator problem, the first one of the entire practice test. Looking at the numbers, it's not bad. It's actually really, really, really nice. So you're probably like, I don't need a calculator. And you're right. But what I'm going to do, just for the sake of practice with this problem, is I am going to show you how to do this on a calculator so that you have the practice and you know what to do in the future. So let's go off to the side and do just that. All right, so in order to use linear regression to come up with an equation, we're going to go to Stat first and Edit. We're going to plug in our numbers on the left. So the x values will go on the left. They started with 0 and then just went up by 1 up until 5. Okay, over here we had 0, and then they were the even numbers, easy peasy. Again, you could do this without a calculator, but the purpose of this is to show you how to use the calculator to do it. Right, so the problem is asking me to find out what r of 9 is. In order to do that, I need to come up with my equation. So I'm going to go to stat, calc, and this is linear, so I'm going to use 4, which is linear regression. Now, since I'm going to use this equation for later, I'm going to store my regression equation into the y equals. So I do that by going to store, reg EQ, hit vars, go to y vars, and hit enter to go into function and enter to store that in y sub 1. So now when I calculate this, it's going to live in y equals. So you go down, you hit calculate. This shouldn't come off as a surprise that based off of the numbers, we have y equals 2 times x, or I guess technically in this case, r of t equals 2t. But if I go to y equals, there's my equation waiting for me. And that's why we do this process. Now it wants me to find out r of 9. So an easy way of doing this is going to second, table, scroll down to 9, and that gets me 18. All right, so let's go back to the problem, answer that, and explain what that means in this real-world context. So r of 9 ended up being 18. Now what that means is this was a t, and this is r of t. So that means after 9 hours, we can expect 18 inches of rainfall. And that's what we get here for A. Let r of x equal x times the quantity x minus 4 times the quantity x plus 2 in the numerator and x squared plus 5x plus 6 in the denominator. State all wholes and vertical asymptotes. I guess we're not worrying about zeros. Oh, I see why. I don't know why there's an Oxford comma there. I'm not going to complain. I'll just blame the person who made this problem, me. So in order for us to do that, I need to make sure both the numerator and the denominator are completely factored. So the top part is good, x times x minus 4 times x plus 2, all over, factoring u is two numbers that add up to 5, multiply out to 6, are x plus 2 and x plus 3. Now there's 5 factors, which means there's 5 magic numbers, and the magic numbers are the numbers that make each factor equal to 0. For example, plugging in 0 makes x 0, and that makes the whole thing up here 0 and all that fun stuff. Plugging in 4 makes this factor 0, plugging in negative 2 makes that factor 0, plugging in, negative 2 makes that factor 0, and plugging in negative 3 makes that factor 0. Now, I'm going to label all of these what I know that they are. Okay, get it out of the way, even though I'm going to accidentally answer B a little bit, no big deal. Anything that has just a factor in the numerator and nothing like it in the denominator is going to be a 0. So 0 is a 0 and 4 is a 0. Now, anything that is in the numerator and the denominator the same amount of times is going to be a whole. So negative 2 is a whole and negative 2 is a whole. Anything that's in the denominator all alone is going to be a vertical asymptote, so negative 3 is a vertical asymptote. Now when we throw multiplicity in here, that changes the game slightly, and you have to worry about which one's more dominant, the top or the bottom or whatever, but it seems like we don't have to worry about multiplicity, not at all. All right, so in order to answer A, state all wholes. Well, my wholes are going to exist at x equals negative 2, so just one of them. So whole is x equals negative 2, and my vertical asymptote is going to live, asymptote, is going to live at x equals negative 3. Now, x-intercepts, you might be thinking, what the heck is that? X-intercepts is just a fancy word for 0. So just, changing the words up a little bit. X-intercept is going to exist at, where was it, 0 and 4. So x equals 0 and x equals 4. Now, how do I figure out the y-intercept? Well, the y-intercept is found by by taking the constant upstairs, so let's say it's 5, and the constant downstairs, and let's say it's 3, and just simplifying that. Well, here's an issue with this. If we look at the problem that we have, Okay, if we were to look at all the factors, technically this could be written out as x minus 0. So if I were to multiply all the numbers up here, all the numbers up here, all the numbers up here, I would get 0 times negative 4 times 2, which is 0. Okay, and so down on the bottom here where I have 6, I would get 0 divided by 6, which means 0 is going to be my y-intercept. Now, why would this make sense? Let me write that out and tell you in a minute. If the x-intercept is 0, that means whatever this picture looks like is going to go through the origin, which means of course the y-intercept is going to be 0. Everything makes sense. Now, this last one's not going to be that much fun, although I purely enjoy it. Okay, my job is to find the equation for the slant asymptote. The slant asymptote exists when the numerator is 1 degree higher than the denominator, and then we do polynomial long division. In order for us to do that, though, I need to completely FOIL this guy out. So I have x times x minus 4 times x plus 2. So let's do x times that guy, x squared minus 4x times the quantity x plus 2. Let's FOIL this out again. X cubed plus 2x squared minus 4x squared minus 8x. And then combining these two, you get x cubed minus 2x squared minus 8x. Now what I'm going to do, since we're going to do polynomial long division, is I'm going to attach a plus 0 at the end because it makes it look pretty. So let's set this guy up. All right, underneath the division symbol, we have x cubed minus 2x squared minus 8x plus 0. Underneath here, we have x squared plus 5x plus 6, and then we do a little bit of polynomial long division. X squared times what is x cubed? X squared times x is x cubed. So you take that x, multiply to this whole factor down here. X times x squared is x cubed. You will always get the same thing here, otherwise you did it wrong. X times 5x is positive 5x squared. X times 6 is positive 6x. Now you subtract that entire row, which means you flip the signs. So you will go away. Negative 2x squared minus 5x squared is negative 7x squared. Negative 8x minus 6x is negative 14x. Drop down the plus 0. And we do it again. X squared times what is negative 7x squared? Negative 7. Now here, I can stop. And if you're like, whoa, 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 whoa. Why? We're not done the problem. I know we're not done this problem. But what I need to do is, in order to find the slant asymptote, you are trying to find what happens before the remainder. I don't care about the remainder. All I know is I'm going to get a linear equation y equals x minus 7. Doing the rest of this problem would serve one purpose and one purpose only, to find the remainder, and I don't need that. So the slant asymptote is going to be the linear equation y equals x minus 7. Okay, so we can stop right there. All right, so this kind of gives us a little snapshot of what this looks like. We know that we have a slant asymptote of x minus 7. We know we have x-intercepts and y-intercepts and holes and vertical asymptotes, and we can draw ourselves a general picture of what this guy will look like. Not that we had to, but we have a good idea as to what this guy will look like. All right, so that is the third free response question. One more to go. We've made it to the last free response question in this fake practice test for Chapter 1. The table below shows the poll ratings of a politician over time. Boo! Is the data best represented by a linear, quadratic, or cubic model? Explain your reasoning. Calculator. So what we're going to do is we're going to let our calculator literally do all the work for this. Okay, so probably for every single problem, for every single problem, we're going to go off to the side and let our calculator do the job. You might be thinking, well, in order to find out if it's linear, quadratic, or cubic, can't we do the thing where we see how much it goes up by and then do it again and then do it again? We can. But if these numbers are not exactly linear or exactly quadratic or exactly cubic, that won't work. So I'm going to let my calculator do all the work. So that's what we're going to do for part A. For part A, we're going to throw this into our calculator. We're going to see what kind of model it appears to be and explain why. So let's go off to the side and do that right now. All right, all right, all right, all right, all right. My job is to find out if all that information is going to be linear, quadratic, or cubic. So I'm going to go to Stat, I'm going to go to Edit, and I'm going to put in all that info. So the month is going to be all the stuff under L1, so that's just going to be 1 through 12. So type that out, or in this case, watch me type that out, like so. Make sure you make no typos. I think I can handle doing 1 through 12. Now for L sub 2, that's going to be the rating. So 1 matches up with 12, 2 with 18, 25, 32. If you don't want to listen to me say the numbers, you can just fast forward a little bit. Or this would be a good time for you to drop a comment. Tell me how much you like my stuff. I see a lot of YouTube videos where people are like, make sure you drop a comment. So that's what I'm doing, and of course while doing this I'm getting very distracted. I can't multitask. What do we have? 35, 42, 49, 56. All right. Now again, my job is to use this information to see if it's linear, quadratic, or cubic. Okay, right now I just have a bunch of dots. If I were to hit graph, nothing. So what I need to do is while I'm in this section, not even while I'm in this section, we'll just make believe that never happened. Okay, this is what I have. In order for me to see the dots, I need to do a few things. I need to go to second y equals to take me to stat plot. Now what I just did is I put a bunch of stuff into stat, which means I gave my calculator 12 points. I'm going to want to hit enter, enter to turn the stat plot on. And what it's going to do is it's going to show me the points. Now there's an issue. My numbers were all double digits, so if I were to hit graph, I still won't see anything. So what I want to do is I want to see those stat points by going to zoom and going to 9 zoom stat. Now what we have here is a picture that goes up, comes back down, and goes up. Now this is not an exact science, okay, but this appears to be cubic. All right, I can draw a line, perfect no, but draw a curve rather that kind of creates a cubic function, okay, that looks like that. All right, so if we were to do the old-fashioned, let's go to the table and find out how much it goes up and then do it again, you're not going to be happy with the results. So by doing it this way, we were able to say, all right, even though it's not perfect, that definitely looks cubic because it follows the cubic pattern. So we were able to look at that information, and even though it wasn't perfect, it's definitely a cubic model because it follows a cubic pattern. Okay, so again, it's cubic because it follows like a pattern that looks like that. Okay, not exact, but close enough. Using your calculator or software, determine the equation for the regression curve that best models the data. Now that we know it's cubic, we can run off to our calculator, use the information that we already have plugged into this guy, and run cubic regression to give us a probably really gross but somewhat accurate equation. So let's go off to the side and do just that. Now, in order for me to find the equation of the regression curve, I already have my information plugged in. So I'm going to go to Calc here. I'm going to go to Stat first. Calc here. We determined that this was cubic, so I'm going to do cubic regression. Now, Part C is going to ask us to use this equation for later use. So before I answer B, I'm going to do something that'll help me for Part C. So I'm going to go down to Store Reg EQ. Okay, I'm going to save the answer that I get into my calculator so that when I do get to Part C, life is a lot easier. So by doing Store Reg EQ, I go to vars, go to yvars, hit enter, enter, and this is now going to save my equation into the y sub 1 part of y equals here. So this will help me for Part C. But Part B is me going to calculate, hitting enter, and getting that god-awful mess. So we're going to write out y equals 0.161 x cubed minus 3.0130, because that's going to round up again, so that will be x squared, plus 19.849x minus 7.364. And so we'll go off to the side and write that out. So we ended up with y equals 0.161 x cubed minus 3.130 x squared plus 19.849x minus 7.364. Use the regression equation to find the average rate of change in the politician's rating from May, which is month 5, to October, which is month 10. Explain what this rate of change means in the context of the data. So I was kind of wrong when I was like, oh, let's make sure we store this into our calculator. I was wrong, but I'm still going to go back and pretend like why that might be useful anyway. In this case, all we really have to do is use the information that we're given. Okay, if we're using the average rate of change, that's this formula right here, the same formula that you used a bunch of times, like so. Okay, U would be my A, and U would be my B, so 5 would be my A, and 10 would be my B, and then U would be my F of A, and U would be my F of B, right? So I'm going to run to my calculator, I'm going to figure out what 42 minus 41 over 10 minus 5 is, which I don't really need my calculator for, but I'm going to show you how to do that anyway because it's important to know what to do with fractions in your calculator. And I am going to demonstrate why maybe storing something like that into your graphing calculator might be useful for a different type of problem. Now to answer part C, what we're going to do is we're going to use that table. Okay, and even though I technically didn't need the equation, I thought maybe I would, I didn't need to. All that information is there stored for me. So if for some reason I asked you to do like the 14th month or something like that, what I could do is I can go to second table, scroll down to whatever I need, and do the 14th month or something like that. But I don't have to do that. I don't have to do that in this case, so I kind of jumped the gun, but I'm glad I did it because it showed you how to store those equations anyway. What I have to do here is use the average rate of change formula. So if I'm going from month 5 to month 10, I'm going to make sure I have 42 in one set of parentheses, 42 minus 41 in the other set of parentheses. Divide that by 10 minus 5. Now, I didn't need my calculator for this. I just wanted the excuse to show you that other thing. This is going to be 0.2, which is 1/5. So let's go back and change that. We're happy now. Thanks for watching. Finish the problem. All right, so we ended up with 0.2, which is also the same as 1/5. So what that means, explain what this rate of change means in the context of the data. That means that you only averaged 1/5 of a point in your rating in these 5 months. Okay, so this was only a 1/5 ratings increase over that interval. Not much, but that's what it means. So that's our last free response question. I hope this helps. I hope watching these videos helps you get ready for everything you might see in a Unit 1 test, whatever that might look like for you. But thank you very much for watching. I'm making Unit 2 and a Unit 3, so more to come, more to come. All right, thank you guys. Love you. Bye.